Hi guys, welcome to today's lesson. Sorry I'm not there today. Today we are looking at the introduction of algebra. Okay, we're going to do a basic introduction. We'll see how we go. I'll certainly be going back over this in class tomorrow or next lesson and hopefully reiterate the learnings out of today. Remember, if you want to have got these questions, you can pause it, you can play it, whatever you want to do, you can replay it. That's up to you. Once you have a look at this video, then I encourage you please to have a look at the two first exercises that I've written out for you. So first of all, my question is usually, what is algebra? Okay, the usual responses I might get will be things to do with algebra is about letters. Some better responses might be to do about letters and symbols representing unknown numbers. Okay, and that's a basic kind of introduction or idea, okay, or description of what algebra is. So we're going to write this down. Make sure you write the heading down, please. Algebra is to do with letters. I'm going to put all symbols, because it could be symbols, Greek symbols like alpha, beta, or even theta later on, with letters or symbols that represent numbers. Now, sometimes we don't know what the number is. Sometimes we might find out what the number is. Sometimes we'll be told what the number is. It can be a whole host of things. So again, algebra is to do with letters or symbols representing numbers. Very, very basic kind of understanding. Now, let's say, for example, you're going to have a party next weekend, right? You don't know how many people are coming to the party, but you know it's going to cost you around about $10 per person who comes to your party. And so your mum's trying to work out, or your dad's trying to work out how much this party is going to cost you. So you might say, okay, well, I know it's $10 per person, so we'll let X be the number of people coming to my party. So we know that if there are 10 people coming, it's going to cost us 10 times 10. If it's going to be, let's say, 50 people coming, it's 10 times 50. 25 people coming, 10 times 25. So X in this case would be the number of people coming to my party. Now, that's a very basic kind of use of algebra. This is what we refer to as an algebraic term. Okay, very simple. Now, we can sometimes have more than one algebraic term. Let's say, for example, using that same scenario as the party, let's say no matter how many people are coming to my party, I still need to buy, some decorations. I want to get some music. I want to get bits and pieces. It's still going to cost me a bit of money before anyone even comes to that door. So let's say, for example, it's going to cost me $200. So we can say for something like this, 10x plus $200 would be the cost of my party. So no matter how many people come, if it's 10, if it's 20, if it's 100, I've still got this upfront cost of $200. So what we now do, we have two algebraic terms. Now, I know what you're probably saying to me, sir, there's no letters or symbols attached to the 200. It's still going to be an algebraic term. Later on, we'll say that there could be a term of x to the power of 0 onto it. Okay, but of course, we don't do that just at the moment. But we can still refer to it as an algebraic term. But often, we'll just talk about them as terms. Not so much as algebraic terms, we certainly can. Now, there are two of these terms. This, in turn, makes up what we call an algebraic expression. Okay, an algebraic expression. And that's important, so let's make sure we write those things down. There are some key terms that we need to understand. The first of all is, what is a term? What is an expression? So an expression is made up of, realistically, two or more terms being added together or subtracted together. They're two really key things that we want to look at. Now, I will talk about, although we're not touching it just yet, the difference between an expression and an equation. Let's say, for example, your mum and dad say, okay, you can have a certain amount of people coming to the party, but it can't cost more than $500 all up. And so you might say, well, 10 times the number of people coming, plus your cost of the party to start off is $200 and equals 500. Now, although we don't deal so much with equations just yet, this is now what we call an algebraic equation. The difference, of course, is we have that equal sign. And that equal sign now means that there is a fixed kind of amount for that x. There's an answer that we can find. We can find out what that x might be using an equation. But again, that is a little bit beyond us just at the moment. The other couple of things that I want to talk about is this plus 200. Let's actually use a slightly different example. Let's say we have 5a, let's say, plus 3x plus 200, right? So this is a slightly different example. We have this time how many algebraic terms? We have 3 of them, okay? We have an a and we have an x here, okay? Actually, let's add on a 4a as well, okay? So now we have 4 algebraic terms. This makes an algebraic expression. Now, I might say a equals an amount and x equals a different amount, right? That would then change the values of these terms, because that would be 5 times 10 would be 50. This would be 3 times 200, that's 600. This one would be 4 times 10, which is 40. I could change the value of a and x, and those other letters there would also change. The one thing that doesn't change is the 200. So we will call him a constant term. Yes, he's still an algebraic term, but we often refer to him as a constant term because he can never change. I can change the values of a and x, but he will always be 200. That's pretty cool, right? So that's another term that we kind of have to learn, the constant term. Now, one of the other things I'll talk about are those letters, right? Those letters can be called different things because you'll notice that those numbers were varying, right? I could say a equals 10 and x equals 200. I could change to a equals 50 and x equals 100. Those numbers can vary. So the letters can also be called variables. And because they're attached to numbers, they can also be called pronumerals. That's another thing that it wouldn't be a bad idea to write down. It's just a couple of different ways that we can talk about the actual letters. We can call them variables, we can call them pronumerals. They're all the same sort of thing. I think I only got one more thing I want to talk about, and that is the numbers in front of the letters. Actually, 2 things. Numbers in front of the letters. So this 5 is what we can actually call the coefficient of a. We could say that the 3 is the coefficient of x. It's a fancy word that we simply use to represent the number that sits in front of a particular letter. Okay, the coefficients of a could be 5 and it could be 4 because there are 2 of them. Okay, so the coefficient is a number that sits in front of a letter. And the last thing you'll notice, that last bit, we have 5a and 4a. Okay, notice that they're same letters, the same variable, the same pronumeral. We would refer to these things as like terms. So anytime you have a letter that is the same number or same letter, it's a like term because, if a equaled 10, these terms, you'd have 5 10s and 4 10s, right? You'd have 9 10s. They're like terms. So later on, we'll do a lot more with like terms. Now, again, real basic introduction. However, there's a lot there to remember. You need to remember the word coefficient, what a constant term is, what like terms are, that letters and variables and pronumerals are the same thing, what an algebraic expression is, and what an algebraic term is. Lots of stuff going on, okay? But we're going to be spending quite a lot of time on this over the next few weeks. Now, what I'm going to ask you to pause this video just for a moment and see if you can come up with the answers to these 4 questions for me. See you in a moment. Okay, how'd you go? How many algebraic terms are there in this expression? Well, we have 1, we have 2, we have 3, we have 4. We have 4 algebraic terms. Yes, I know you want to say 3 because there's no letter on the 7. It is still considered an algebraic term. Okay, now, the constant term. Did you get this one right? The constant term, of course, is 7. It's the only one that doesn't have a letter, variable, or pronumeral attached to it. So it's the 7. It is constant. It can never change. The coefficient of b. The coefficient of b would be that plus 3 up there. Okay, of course, we don't need to put the plus there though. If it was a minus, we would have to put the minus, but we just put the plus 3 or a 3 there is fine. And the last one there is, are there any like terms? Yes, there are. We have the 5a and we have the 6a. Now later on, we'll add those together to make them 11a's, okay? But that's for next lesson. So like terms are where the pronumeral or variable or letter is the same, and we had that on both the 5 and the 6. Okay, hopefully we went okay on that one. All right, we have 2 more questions, I believe. Now, this one is where we want to write an algebraic expression for these words. So these are sentences, we want to condense them. So just for example, 3 more than x, you write something like x plus 3. That would be your algebraic expression. So we're removing those words and we're replacing them with algebraic symbols or mathematical symbols like the plus sign. Now, in this case, some people might say, sir, could I do 3 plus x? And absolutely, you could do that in this instance. It would still be the same expression. However, if I said, what's 3 more than 10? You'd say 13. I'd say, why? You'd say, oh, because I added 3 to the 10. So see how here I'm adding the 3 to the x. It's a good habit to put the plus 3 where I've got it there. The second one is a bit more challenging, of course. 5 less than y. Well, if I said, what's 5 less than 20? You'd probably say 15, because 20 minus 5 is 15. Well, same thing here. We're going to say y minus 5. Now, I know what you're going to say. Sir, can I say 5 minus y? Would that be the same thing? And my answer, unfortunately, this time is no. And that's where it gets a bit tricky. Because think about your y being that 20 that we spoke about. 20 minus 5 makes 15. We get that. But what's 5 minus 20? Well, that's negative 15, and that's a different number. So we can't say that way. That's why I like putting the letter first in these instances so you don't get them wrong. Now, again, I've used some here. I mean, you're happy to pause it, but there are some words here that you might not remember. Okay, for example, do you remember what product means? The product of 2 numbers. Well, product means times or multiply. So this means 4 times f. That's all it means. Now, you might have written this, if you've looked at a bit of algebra before, apologies, you might have written this as 4f like that. If you did, fantastic. But you don't have to at the moment, okay? We're kind of building towards that. But product means times, multiply, etc. What about the quotient? Does anyone know what the quotient means? Okay, I use that one particularly because it's a tricky word, right? The quotient is actually the opposite of the product. It's divided by, or a fraction, okay? So you might say A divided by 7, that would be correct. Now, like the example above, of course, later on, that won't be correct because we want to simplify it. And the way we do that, instead of using the divided by symbol, we use the fraction symbol. I know it doesn't look much more simplified, but we are considering that to be the simplified form. Again, that's down the track. If you just remember that quotient is divided by, I'm a happy man. What about the next 3? Okay, these are some tricky ones here. E. Q is halved and then 3 is added. Well, how do you halve something? So if I say, what's the half of 10? Now you might say 5. Well, how'd you get that? Well, you divided it by 2. So again, you might say Q divided by 2 and then 3 is added. I'm going to plus 3. At the moment, yeah, I'm happy with that. I'm okay with that. Next week, no, because I don't want the divided by looking like that. When we're looking at algebra, I want to say halving like that. We put it as a fraction, and then I can put my plus 3 and add it on there. Okay, so that's probably my preferred measure at the moment, if you can do it. Okay, all right. What about the square of t? Can you remember what the square of something means? So like if I said, what's 3 squared? Well, that means 3 times 3, right? Which is 9, or 3 to the little power of 2. So the square of t would just be t squared. Now, if you said t times t, it's still correct, but guess what? That is more simplified. It's more condensed, okay? But the square of something would be like a little 2 there. The cube would be a little 3. And the last one, 3 times the sum of 5 and m. Now, this is a much harder one because a lot of people would say 3 times the sum of 5 and m like that. But unfortunately with BIDMAS, what that would actually say is 3 times 5 plus m. Okay, we want to say 3 times the sum of 5 and m. So what we'd actually have to do is putting brackets in there so that we're showing that we're adding 5 and m together, and then we're timesing that whole thing by the 3. Or some of you who may have done this before might write it like this. And again, that's perfect. That's a really nice way of doing things. But again, that's down the track. All right. I know this might be a bit much, but this is what the kind of work we're doing today. So make sure you kind of watch this and help use this to help you answer your questions. Now, if you are a little bit ahead and you're smashing through the work today, okay, we can look at a bit of substitution. And all this means is we're taking the letter out and we're replacing it with the number. So for example, if x equals 2, 5 times x, well, this is kind of like the party question, right? Okay, this means 5 times 2. And what's 5 times 2? Well, 5 times 2 is 10. That's it. Now, the only thing you had to know there was that when you have a number and a letter next to each other, you are timesing them together. 5 lots of x, 5 lots of 2, 5 twos are 10. Next one a little bit easier. X plus 4. Well, if x is 2, and I add 4 to it, we get 6. So see how these questions, because we're being told what x is or what y is, we can actually evaluate it. We can actually find the value of that expression. Where previously we couldn't. We just left it as x plus 3 or x plus 2. What about xy? Well, they are next to each other. That means x times y. So 2 times 3, and that's going to make 6 as my answer. Okay, and the last one here is 6 times y, all divided by 2. Well, that makes 18 divided by 2, and that makes 9. Now, that last example, I'm not too concerned about because that's what I'm going to do next lesson. I'm going to reiterate all this stuff, and I'm going to jump back into our substitution. Hopefully, though, it made a little bit of sense and it gives you a bit of an idea of algebra and gives you a bit of a place to land off for today's lesson. I hope you all, guys. I'm going to see you next lesson, and then we'll really concentrate on this algebra for the next couple of weeks. Have a great day.